Welcome back, Pre-Calc. We are going to get into the unit circle. This is some pretty important stuff, as this is really the meat of pre-calculus and things that a lot of students have memorized, and the big part of trig is the unit circle. Now, because I'm using somebody else's material, evidently this person likes to explain things based off of the known assumption. Oh, you could do the math to figure out that 45 degrees is pi over 4 radians and 30 degrees is pi over 6 radians. But instead of explaining it that way, I'm going to do a full picture for you. And if you follow the directions, they want the radians on the outside of the circle and I think the degrees on the inside, but whatever. But the whole premise of this unit circle is that 0 degrees matches up with 0 radians, and also I'm just going to add another blank right here, that 360 degrees all the way around the unit circle matches up with 2 pi radians. And then from there, you can divide each of those by 2. Well, if we divide by 2, we're at 180 degrees, which is on this side of the unit circle, a straight line. And if you take 2 pi divided by 2, then you're at pi radians. So what I'm going to do is explain this based off of that knowledge, is that if you were to cut 180 degrees in 2, you'd be at 90 degrees at the top of the unit circle, this point right here, which is at, well, if you did that with pi then, that'd be at pi over 2 radians. And we can do that one more time pretty easily. That 90 divided by 2 would give me 45 degrees right here, which would then correspond, if you did that divided by 2, you'd be at pi over 4 radians, which is confirmed by this teacher's assumption or assertion that you know that. So let me just get a highlighter out real quick, because if you break this into pieces of pi, so to speak, that right here is a whole pi, and then by dividing in 2, we're at pi over 2, and dividing that again, I think you can see if I broke this unit circle into that you have 1, 2, 3, 4 pieces. And I'm going to assume that you're probably familiar that, pi over 4 plus another pi over 4. I hope this is showing up for you. Pi over 4 plus another pi over 4 is equal to 2 pi over 4, which would give us 2 pi over 2 if you reduce that. Probably shouldn't have done that in such a yellow color. But anyway, which makes sense then, if you have 3 of those pieces, then you'd be at 3 pi over 4 over here. And then continuing that trend on, which I guess I should also assume that you would recognize that that's 135 degrees. Continuing that into the third quadrant would be at 225 degrees, or 5 pi over 4 radians. And you may have noticed that in the first couple of units in this, first couple sections of this unit, I was saying how quickly you'll be able to know this in the future, because, as you practice and you get a lot of noticing these patterns, it comes out pretty quickly. And then over here it's 315 degrees, which would then get me to 7 pi over 4. And again, you can continue this. There's 1, 2, 3, 4 pieces, 5, 6, 7 pieces over here to get up to 7 pi over 4. And I'm going to use the same breaking down knowledge with a different highlighter, though, and looking at these other pieces. So 1, 2, 3, 4, 5. I guess I need 1 all the way across as well to make it 180 divided by 6 would give me 30 degrees. Well, pi divided by 6 gives me pi over 6. I think from this you can see, and ignore the yellow highlighter now, I'm looking at this greenish highlighter, that there's 1, 2, 3, 4, 5, 6 pieces to get up to pi. And how can that help you as well is, now we don't typically call this one 2 pi over 6. Let me use a light color here, because this one is pi over 6 plus pi over 6, which would give me 2 pi over 6, which is how we get to that expected, that you know that that is pi over 3. But you can use the same knowledge that, like, I guess I'll just use my black pen right here, that there's one piece, and then there's a second piece, and then a third piece to get to 3 pi over 6, which gets us there. And I mean, we can continue this trend on as well, like pi over 3 plus another pi over 3 would give me 2 pi over 3. Or you can think of this as 4 pi over 6. We just like to reduce everywhere. And this is 120 degrees. This point would be 5 pi over 6. You can see why I'm better at radians than I am with degrees. And then moving into the third and fourth quadrant, we just do the same thing. 210 degrees. This would be 240 degrees. And you can see continuing this trend, 7 pi over 6. This one would be not 5 pi over 3. So wrong. 4 pi over 3. 300 degrees. Matches up. There's 5 pi over 3. And then 11 pi over 6. Which is 330 degrees. So there's a lot of shortcuts here. And I should probably zoom out so you can see the whole thing. But in the unit circle, these are the special points where we know exact values on the unit circle. Okay, and if you ever get lost, you can always Google the unit circle. You'll get a whole mess of things. You'll even get other people's explanation on the unit circle. And I'm totally fine if you use other people's explanations. So if for whatever reason you can't see all of my degrees and radians on here, you can go back and see. Now what you should notice from here is there's definitely a pattern going on, and it's all based off of the reference angle. Is as long as you know the reference angle, then you can figure everything else out. So what am I talking about? Is, for instance, I can get back to my highlighter, this 210 degrees matches up with the 30 degrees. And there's a couple ways you can think of it. Is it makes the same angle with the x-axis, or you could just say, just do 180 minus, and they line up. Notice that the radians, the denominators are the same. And this should make sense because you're just 1 pi larger on this side. And that works for all of these. So the whole point that I'm trying to get at is there's definitely a pattern between the reference angle, the denominators. See how all of these have a 6, 6, 6, and 6. And there's even a pattern with the numerators. Everything in the first quadrant is just pi over whatever. In the second quadrant, the numerator is exactly 1 less than the denominator. And that should make sense. I say should because you're just taking away 1 pi over 6 from getting up to pi. Same with this one. You're taking away 1 pi over 4 to get up to pi from 3 pi over 4. Same thing with that one. And using the same exact logic, then, the third quadrant, the numerators are exactly 1 more than the denominator because you're adding 1 pi over 6, 2 pi over 6 to get there. And then using a very similar logic, the fourth quadrant is 1 less than double the denominator. And why is it 1 less than double? Well, if the numerator was double, we'd get all the way up, all the way around to 2 pi. So by removing 1 pi over 6 from 2 pi, that would be like 12 pi over 6, which is 2 pi, minus 1 pi over 6. Now, a lot of students will just memorize this, and that's fine, but there is a reason why the numerator is 1 less than double the denominator. The numerator is 1 less than the denominator. The numerator is 1 less than the denominator. I didn't say times 2, but the denominator times 2 minus 1. The denominator times 2 minus 1. The denominator times 2 minus 1. So once you recognize this pattern, everything else will fall into place. And I'm not going to try and rush through the second slide of this. So I'm going to stop this first video right here.